prove that this was the causal agent. Shortly after that, in 2007, then the links on this problem became more evident. This new beetle that was found in 2002 in the Fort Wentworth town was shown to be the vector of this new fungus. And Jorge's going to show a photomicrograph of it later on, but in these insects, and this one in particular, there's a little pouch behind the mandibles. This is the mandible or the mouthpiece area of the insect, and then right behind that there's a little pouch called a mycangium. They've got paired mycangium. In those mycangia, this fungus then is found in high numbers. This is typical for these ambrosia beetles. In 2008 then, this new fungus, its brand new science was described. It's called CAAvoGrowers now. We know that it's related to other ascomycete pathogens in trees, in particular the one that causes Dutch elm disease. So that Ophiostoma group includes some plant pathogens. Most of those, however, that are related to the ambrosia fungi and ambrosia beetles are not pathogens or saprophytes. So right away, as we began trying to figure this disease out, there are two really conspicuous things that really stood out. This insect is attracted to healthy trees. That's really unusual. Ambrosia beetles in general grow dead or dying trees or dead wood. Female born into that wood, and then she, in these natal galleries that she pours into these trees, will cultivate these ambrosia fungi. And it's on those fungi then that these progeny, larvae, develop and subsist. They don't eat the wood, they eat the fungus. So the weird thing is that this thing is attracted to healthy trees. And the other odd thing too is that these fungi are usually saprophytes.
Okay, thanks a lot.
They live on dead tissue. This thing, however, is a bona fide systemic virulent pathogen on red.
We'll talk to you soon, okay?
Very unusual situation. This disease has progressed very rapidly. I'll show you a map here pretty soon of the current distribution of it. But one of the reasons it spreads so rapidly is that there is a map comes back on. There is a map of the southeastern U.S. and it has gray areas of varying intensities. It just shows the distribution of red bay and the relative abundance of red bay in these different areas. The map to show is that red bay is very widely spread, and we know that it's extremely susceptible to this disease. Because of that, this epidemic has progressed rapidly. The other things that have been responsible for this rapid movement are the great efficiency of this insect vector. This insect very effectively moves this pathogen from one tree to another, and it's highly attracted to red bay. The other thing that has caused this epidemic to move rapidly is the movement of firewood. Red bay it's got a very aromatic smell. And what's happened is that people use it for electrical barbecue. People, when they see a dead red bay tree, have cut it down and have used it for them.
So you just like the rounds? Yeah.
Have used it then. Go ahead.
Yeah. Is he here?
And spread widely then unwittingly in firewood, removing this dead material that
bring him by your
encrusted
office?
with the insect and the pathogen.
Let me talk to him.
And you can see in this map, this is, Jorge's got a more current map. It shows the distribution of this disease and how rapidly it spreads. So if you see the red counties up here, this is Savannah, and there's Fort Wentworth there. There's Those red counties were the first counties in which Laurel was found. Very quickly after that, it spread. You can see it's all the way up into North Carolina now. We very recently in Dade County, got up way down here in the southern tip of Florida, and it's gone as far west as Mississippi. That report was in 2009. So what you should notice from this distribution map is that most of these counties here are, the distribution in subsequent years is contiguous counties, but there's some big jumps. For instance, from here in the Panhandle all the way out here to Mississippi, that were probably not the result of the natural vectoring of the pathogen by the insect, but instead were because people were moving forward. So that latter thing is probably going to be the way, if this thing makes it to California, that you're going to get it here. We've talked in the last two talks, we've given the same talk to two previous audiences, and the take-home message that we all would give you is, if you have any influence at all, keeping firewood out of California, or keeping plant material out of California that might bring this pathogen or vector in here, please do so. This is going to be a really difficult problem to manage. It's going to be much more difficult once you get it here. The easy part is to keep it out. Once you got it here, it's going to be really tough. Anyways, this is the kind of damage that's done in Georgia. This was in 2009. And this was, used to be one big monoculture of some very large redbay trees, and they, two individual are dead. So, some pretty widespread devastation on this native tree. In 2006, the disease was first found in Florida, and then shortly after that, in 2007, the first avocado tree went down in the landscape. So then got our attention. We worked on avocado trees. It became clear that this other tree in the Laurel avocado was also susceptible to some redbay. What are the symptoms of Laurel on avocado? Initially, you'll have this very quick wilting, and seeing these branches here, the leaves will become kind of an ashen gray, or kind of an oily gray, before they become completely dried out of the ground. Avocado will, unlike redbay, will foliate within about 2 months. And then another typical symptom of this disease is this sectoral development of disease. This tree here on Merritt Island in Florida, you can see this right-hand side of the tree is healthy, but the branch or the trunk on the left-hand side is dead. So this sectoral development, you'll have a portion of the tree die or be affected, but not the entire tree is sort of common as well. Cut the trees open, again, you'll see this indication that there's something going on in the sap. Think back to that tree that we saw of the redbay that the Steve Federal group was working. Same type of symptom. You can have a kind of a grayish discoloration or kind of a reddish-brown discoloration, but it's just an indication that the xylem is reacting to this invasion by this pathogen. And that's a fairly diagnostic symptom. Jonathan will talk later on about diagnosing this disease. There are some other problems on avocado that can look like this disease. So we have been trying to educate our growers in Florida as to, if you've got something that looks like Laurel, make sure it is Laurel before you start cutting trees down. There are other things that will limit this damage. Eventually what will happen in these affected trees is you'll have evidence of vector activity. And you see these little tunnels right here. There are a lot of other ambrosia beetles that visit these avocado trees as well. And this is one of the things that Jorge and I are interested in. We know that CAAvoGrowers calibratus, this new redbay ambrosia beetle, we know that it is a vector of this pathogen. We're also interested in what about these other beetle species that we know infest avocado. Are they potential vectors as well? So that's a topic for future research. Okay, so I'm going to talk about the disease type of research that I've done so far. I've spent a lot of time on this in the last 3 or 4 years, and I'm just going to give you a brief synopsis of the